for this particular problem, to integrate this, your first question is, can I integrate it as is? And it's a no, because this isn't a polynomial. This isn't just an easy integral. So then you go, okay, is U substitution help me? Well, actually it does, because if you set one piece and derive it, do you get the other piece? Yes. So this is an U substitution problem. And what you look for U substitution is you look for which piece is embedded in something else, like a square or a cube, a square root, and this one, the cosine, is inside of a squared. So if we make cosine U, the integral of cosine is positive sign or negative sign? I know it's sine, but is it negative or positive? Well, the derivative of sine is cosine, correct? So the integral of cosine, should that be sine? Or is it negative sign? Is it negative sign? I always mix it up. Is it negative?
Yeah.
We'll go with negative. I should have looked at that and remembered, but I didn't. Anyways. So, from here, we now, dx. So you have to divide by negative 1 real quick. And you now get negative 1 in front. You got u to the negative third du. Because u cubed, but it's on the bottom, so it's negative. Du replaces, du over negative 1 replaces sine x. So your answer, or your next step, is going to be negative 1, and then you add 1 to this, so this would be u to the negative second divided by negative 2, and plus c. 2 negatives becomes a positive, so we now have 1 over 2, and then u is cosine, so it's going to be cosine squared x plus c. Again, don't forget the plus c. It's very easy to forget plus c. Try not to forget that. Okay. Now, number 68. Any questions on 54? All right, 68. Here we go. This is another U substitution, but it's a little weird. U, for this particular one, is what's inside the square root. So du, when you derive this, is pathetically easy. It's simply dx. But the problem here is, when I rewrite this, I end up with, okay, 2x plus 1 over the square root of u, and dx replaces du. That does not help me at all at first glance. But here's where the special case or situation you have to mess with is what you have to do is you have to go up to this equation and you have to rewrite it and replace your x up here with u. So what you do is you rewrite this piece and then you just basically get x by itself, so you minus the 4 over. So you have now x equals u minus 4. Now can I go and take this bad boy, stick it right there, and I get 2 u minus 4 plus 1 over u to the 1/2 du, which that would be 2u. Now when you distribute, doesn't that become negative 8? But negative 8 plus 1 is, I believe, negative 7. Does that look right? Over u to the 1/2. Now some people would go, now I'm in trouble again. But this is actually possible here. What you have to do here is divide both pieces by u to the 1/2. So u over u to the 1/2 becomes 2 u to the 1/2, because that's a 1 power, so back to powers. And this one would be negative 7 over u to the negative 1/2 du. So again, when you divide both by u to the 1/2, now we can integrate this, and it looks like we're going to get 2 u to the 3 over 2, And won't that be a 2/3 here? Okay. Is it 3 over 2? Minus, we got a 7. And when you do u to the 1/2, divide by 1/2, won't there be a 2 right there? Don't forget plus c. So my answer, as I put my u's back in, first of all, 2 times 2 is 4. And then u to the 3 over 2. U was x plus 4 to the 3 over 2. That's over 3. Minus 7 times 2 is 14. And I could leave it as 1/2 or square root. I'll leave it as 1/2 because this is already a fraction power. This was x plus 4 is u again, plus c. That looks like the answer.